have something very special tonight, a sideshow. And what that means is that over there on that side, there's a show. And I'm not joking. So what we've... Darren Lutze has got a keynote presentation for us. And those of us without X-ray vision, we can wander into that side room. So there's, can you give everyone a wave, Darren? Great. Darren will introduce himself in the presentation. So we weren't able to have a backdrop and a presentation screen. So this is a memory task. You've got to remember where you're sitting now so you can come back to those seats in the future. But we're actually going to stand up and hang out in that room and just for 15 minutes enjoy Darren's presentation. Let's go to it. And remember, you can still do your bingo. And then we'll come back here for a wonderful panel discussion.
Go for it. Okay, if everybody's in, thanks very much, and I too pay my respect to past and present. I'm the CEO of a company called InconMat. We specialise in durability. We started back in 2009. I'd been exposed to a product called GFRP rebar, and I thought it was going to change the world. And I think it still will, but it didn't happen as fast as what I thought it would. So just go to the next one. When I was asked to put this presentation together, I put a bit of thought into it, and I come across this in one of my social media links. And to me, I keep looking at that statement, a society grows great when old men plant trees, the shade of which they know they'll never sit in. Now we know that. Our forefathers didn't know that, and we can't look back, we have to look forward and leave a legacy. I mean, we all got children, we're all going to have grandchildren, and it's our responsibility to leave a better place. So, as you can see, running this type of business is not easy. That was 12 years ago, and I wish I still looked that good. But, and of course, my sister is my business partner, and we've got associated other shareholders as well. So back in those days, there was very little imagination for durability, which in fact goes hand in hand with sustainability as well. There was, the industry such as concrete galvanised associations, they've always been for the last 50 years trying to make steel and concrete more durable. It hasn't really worked like they expected to. So I'd enter into meetings with this bit of rebar I bought back from Canada back in those days. I say, I've got a solution for your problems. And people would say, what problems? We haven't got any problems, what are you talking about? And then because this behaves so much different than what steel does in concrete, they would say, well, even if we do have a problem, even if corrosion is costing us money, you're going to expect me to put my name to this product? No, there's no way in hell that's going to happen. So we started a journey, and the journey has taken lots of twists and turns, and no matter who you talk to, everyone has a different take on it. So imagine back in 2010, I'm this guy, I'm not an engineer, I'm a farmer, ex-farmer, truck driver, and I'm sure many engineering presentations I went to was like, who the hell's that guy? Who does he think he is? Asking me to take out steel and put this in concrete. But you got to understand from an engineer's point of view, they're all about risk mitigation. And they didn't learn in engineering school how to design with this material. So to them, it was very risky. Why would we do this? And so there's a lot of fear. They don't know how to do it. And I was just mentioning before to France, with a project with Dipty back in the day, they went to one of their consulting engineers, and the engineer actually said, yeah, I don't know how to, but the conversation was, no, he can't. So what we've, and people, all of us, none of us really want to be the first with anything. You go to a sideshow, that looks like a great ride, but I don't want to get on there, I want someone else to do it first. And so people, engineers, think about liability, responsibility, and even though you've said it's been done before, in another country, like before we started here, there's 20 years worth of projects in Canada, still successfully standing today, and they will be for hundreds of years. So it's been done before, so you'd tell people it's been done before, and then they say, but it hasn't been done in Australia. Goodness me, we've a different sun or something here, but no, it hasn't been. And then even once you've done it in Australia, we've done it in Sydney, you go to Perth, hasn't been done there. I mean, goodness me. So that's me, like just confused, like how the hell, what's the problem? Next one. So what we did is we had to start listening really carefully what the pain points were. And for an engineering firm that have always followed the standards and the codes, what's in it for an engineer to change? There's really nothing. They have a business to run. They risk adverse, and then we have the competitive tender process, and that's prescriptive. So we might have a group of engineers that really like it, but they know it's going to take extra time to engineer with this product, so they don't put it forward. And even if there's a champion in the organisation and if he leaves, or he or she leaves, they lost. So the questions we get asked, is there any design software? And then you get project specified, as you're going to see in a minute. It's not that nothing was happening, but then it comes from overseas, and what about the risk to the project? And what I've learned over the last 10 years, there doesn't seem to be much incentive for anybody to innovate, which is really sad. And the amount of meetings that we used to go to, and I must say it's not as much as what it used to be, who cares? I'm not going to be around. And it's just dumbfounding to me, and to all of us it should be. We should care.
Sorry.
Right. So what we've done is we've become a specialised company. Yeah, sure, we sell products. That's what we do. That's how we're a commercial company. But we also understand that the in-depth multiple restraints that engineers and designers face, especially for products they've never learnt in university. So we've had to become an educator as well to move these products. So we assist, and all I want to say is it's so heartening now, after 10, 12 years in this space, is when we do engineering presentations, people actually pay now. Like before, you couldn't give these tickets away. We've always brought in international speakers. We've done that every year. We collaborate with universities. And so when we couldn't give our sandwiches away 12 years ago, now we're selling tickets $300 or $400 a ticket, and people are turning up to learn how to design with a sustainable material. So it's very, very heartening to see this. So in regards to listening, there's no software for this material. So for an engineering firm, they can't operate the same way as what they've always done with steel. So I always said, we're going to do some software, we're going to do some software. So I was doing a presentation similar to this a few years ago, and this professor from Kansas University comes up to me and says, I want to talk to you about software. And I couldn't wipe a smile off my face for about a week. It's what we've been looking for. It's the golden egg. Now engineers can operate in their offices at the same time frame and speed, with the same accuracy in what they do with their steel design software. So we've just released this through back one. We just released this a couple of weeks ago through Engineers Australia, and we had over 430 engineers online at the presentation. So anyway, we keep skipping that slide. That's all right, no problem.
Yeah. There we go.
So again, that's one of the software riders on the side, and that was presented a few weeks ago and about to go live on our website shortly. Next one. So corrosion, sustainability. It's a $13 billion a year problem in Australia, and remember what I said before, what problem? But that's fact, that's the problem, that's what it costs Australian taxpayers, community, business owners every year. So the corrosion problem, just some figures here in the middle. In 2016 ice roads, 12,000 concrete bridges, only 1% of them make their intended 100-year design life, and many start to deteriorate after 30 years. So there's definitely a problem. We spend a lot of time, not a lot of time, that's not the word, we invest a lot of energy into collaboration with universities, leading universities around the country, including all 3 state universities here. These are presentations from University of Southern Queensland, Professor Manalo. So again, listening, and this is commercial. We've now got all our contracts, investment on through, and by just a bit after Christmas we'll be making this locally in Australia, and that means from a software point of view, from an engineering point of view, to a supply point of view, we operate in the same type of manner as what a steel reinforcing company will do, but we're a GFRP reinforcing company. Yeah. So this is an interesting little project we did. It doesn't actually say that, you'll see it on the next slide. So sustainable procurement's come into vogue now as well. It's good to see. And we're adopting social and economic and environmental factors alongside the typical price and quality considerations. So traditionally everything has been on price. So a tender gets pushed out, everything gets down to the cheapest. So that's at the CapEx, and then the CapEx hand is not talking to the OpEx hand, and we've got these problems that we see. So, the greater city of Geelong has used innovative procurement, which give us the opportunity to stop the normal process, go out and find solutions for real problems. And next slide. This project here, we ended up as a group of us. So Ostens, Rockler and Inconmat, can't even say our own name probably. We ended up getting together. We designed. Inconmat did all the engineering. Rockler supplied the geopolymer concrete, which is not Portland cement, so there's no CO2 or very little CO2. And we built these two bridges in Geelong. So the first one's built in the country. Yep. So this is just some snapshots. As you can see, it looks like steel. It's not steel, it's fiberglass. The concrete is all geopolymer, like I just said. I'm very, very proud to win this award in the last couple of days. I wasn't there, but Institute of Public Works Engineering Australia, we won the award for excellence in environmental sustainability, excellence in innovation and excellence in public works. And the amount of inquiries we're getting out of this is incredible, and from around the globe, not just Australia. So as I said before, we've always worked with universities. Alan Manalo, I've worked with him now since 2010. This here is a state of play of reinforcing materials. And just like everything else, it has to be made to a code and standard, but we won't get into all that now. Next one. So this is a project, this is great. It's just a boat ramp plank. Now when we started on this project, with the Queensland Government Transport and Main Roads, they said, well, they last 30 years, what's the problem? And we said, well, why don't you have them last 100 years? And they go, well, what about if they get washed away in a storm? Well, you pick them up and put them back in again, because you now own this asset. It doesn't rust, it doesn't corrode, and you own this asset for the next couple of 100 years. So that's published on their website, and we built a lot of those boat ramps in Queensland. Most of our work is governments. Yeah, keep going. Now, what these two states have done, so New South Wales and Queensland, even though there's a code committee at Standards Australia, they've gone ahead and written their own codes. They couldn't wait, which is excellent. Keep going. So just a quick few snapshots of projects we've done. This jetty here is in Western Australia. All the concrete you can see is all reinforced with this material. Next one. Local jetty up here at Whyalla. We're supposed to have more concrete on that, but that's what happens when contractors get hold of things. That one there, that was done by a local engineering firm, WGA. They're a very professional company that's seen the light with this material right back in the early days. More jetties. Okay, going. This here on Sydney Harbour, everything you can see here again is all reinforced with GFRP. And there's probably 30 odd projects being done now on Sydney Harbour. Sydney seawalls. It's used a lot also, nothing to do with sustainability, but it doesn't conduct electricity or signals, so it does interfere with signal loops. Wind farms. Just go back one. Oh, and it also has another side, since we're having a big argument here in the state now about a nuclear waste dump, it doesn't radiate either, so it's good, it never radiate. Okay. Yeah, just many projects like this. Just push play on. Okay. So this project here, it's the first multi-storey building done in the world, and we're proud to say that we engineered it and supplied it. This has nothing to do with sustainability or durability, in fact. The reason this was used for is electron microscopes, and the signature that any steel or even stainless steel would interfere with the performance of those microscopes. So this building had to take into earthquake, fire ratings, all the general normal building codes. And so for the naysayers that used to tell us it can't be done, well, it can be done. If you want to build a jetty, we can build a jetty. We can build a multi-storey building. We've proven that. Yeah. Yeah. Yeah, as you can see, anyway, it looks like normal steel, but it's fiberglass. As I said before, we've always worked with universities. That's our collaboration strength. By working with the universities, young engineering students come out to the field very comfortable with the material because now it's part of their curriculum. With our software as well, that'll be rolled out to every engineering department in every university over the next 12 months or so to use free. Yep. So there's the two good-looking people there. So what we've done here, this is with the University of South Australia. All this is here, we can engineer all these sections, so these are driven piles in a jetty. We just wanted to do a study of these joint details, so that was a university student project as well. There you go. Again, this is with a fellowship grant in Queensland, so we're working with the Transport and Main Roads and the University of Southern Queensland. This is to develop a sustainable infrastructure, future-proofing their infrastructure up there. Yep. Yeah, this is, again, university projects. This is power poles, next one. So we've got 6 of those power poles going into WA Power next year as a trial. So they've all been engineered. And as you can see, concrete doesn't normally bend like that, but with this material, we won't get right into it, we get to all engineering speak. Yeah. Sorry. Now, so the other side of our business, which is something we've only just got involved with in the last, just before the pandemic, is bioenergy. So, as we all know, we all know these statistics. Food waste accounts for 3% of Australians' greenhouse. Millions of tonnes of food are wasted, and when food rots in landfills and creates methane gas, it's 25. That methane is about 25 times more damaging to the environment than carbon dioxide. And all we care about, or seem to care about, is carbon dioxide. So there's a number of companies. We really only just started in the industry to supply anaerobic digester tanks, and now that's morphed into engineering from the beginning. Supply, build, construct the whole way through. So there's many types of feedstocks that we can use, restaurant waste, cow manure, all this type of thing. And with anaerobic digestion, we can scale very quickly, whereas with the buzzword hydrogen, that's a discussion for another night. So there's a lot of community project opportunities. Okay. So we were very pleased.
Can I just check, Darren? I'm so sorry to interrupt. We will have our panel discussion fairly soon. How are we going?
About 3 minutes.
Wonderful.
Yep.
Thank you.
So we were very pleased to see the signing of that agreement yesterday. That's going to help our industry. Yep. Keep going. So this is I've been told to hurry up. So this is our.
Sorry, Darren.
Keep going. So. This is a community project in Toronto that we're trying to establish in Australia with varying different people. So it's actually Toronto, what do you call it? It's zoo share. So the zoo waste and the waste from the community will go to this process, which is great. Just play that video and then we'll finish it up. So that's some of our partners. We've got about 5 different partners. Next one. That's a biogas plant. So waste to energy, and also through plasma technology, we're turning methane into hydrogen as well. But that's a whole other story. Yep. That's what our tanks look like when we're constructing them. Yep. Some of our partners, Enpro Envirotech, Dr. Jane Kessler couldn't be here tonight. Yep. And
a society grows great when old men plant trees, the shade of which they know they will never sit in. Good people do things for other people. That's it, the end.